In the beginning, man believed flight to be the privilege of mythological gods. The gods of Crete, of Egypt, of Assyria, and of Greece. As man's capabilities developed, so developed his power to dream of his own ability to fly. Leonardo da Vinci, whose genius stands in marked contrast to the ideas of his contemporaries. If it were not for the dreams in his fertile mind and the dreams in the minds of generations that followed, there would have been no tomorrow. Throughout history, throughout the world, the achievement of sustained, controlled, and powered flight eluded man. The dream was there, but never fulfilled. Sir George Cayley, with his revolutionary wing designs, solved the problems of lift. Steam and clockwork planes followed in 1857. Moszewski's 1884 steam plane almost succeeded. Then, in 1903, the Wright brothers flew and created fresh dreams in the minds of the young. In the struggle to realize the dream of vertical flight, one man stands out as a pioneering giant, Igor Sikorsky. He was the first man to design, build, and pilot a multi-engined aircraft. He held, during his long career, 10 world records, both as a pilot and designer. But above all, it was his dream of vertical flight, which he eventually realized, that made him the father of the modern helicopter. The helicopter is now such an essential part of our modern life that it's difficult to imagine that it has been with us for only 40 years. Its uses, as Sikorsky predicted, are boundless. Rescue, transport, supply, construction, and latterly as a highly sophisticated combat machine. Looking at it now, it seems remarkable that its designer was already a young man when the Wright brothers first flew in 1903. Remarkable also because he built his first prototype helicopter in his backyard in 1909, and that it was built not in the advanced countries of the West, but in the relatively backward Russia. In fact, Sikorsky confounded his critics, his circumstances, and on occasion, death, to build a company that has become the largest single producer of helicopters outside the USSR. Igor Sikorsky was born in Kiev in 1889, the youngest of 4 children, and came from a respected middle-class family, his father being an eminent child psychologist. From the beginning, his family encouraged his interest in the modern technology that was beginning to filter through into Russia, and as a result spent several years studying engineering at the Naval Academy in St. Petersburg. But the strongest influences on his early years was his fascination with manned flight, an obsession that was to shape his whole life.
When my father, Igor Sikorsky, first began to dream about aviation, aviation as such did not exist. His first interest in aviation was sparked by the drawings of Leonardo da Vinci describing the helicopter and also describing various flapping wing mechanisms to allow man to fly. His dreams of flight were then, I believe, crystallized in a uniquely prophetic dream that he had at the age of 12. And if I may, I'd like to very, very briefly frame it by saying that at that time, in 1900, man had not yet flown. We were 3 years away from the Wright brothers. And this 12-year-old boy had a dream. And in this intense photographic dream, this 12-year-old boy in Kiev, Russia, sensed himself walking down a very narrow, wood-paneled cabin, strangely vibrating, somewhat like a fast-moving boat or railway car, but not quite. In his dream, this 12-year-old boy walks to the window, looks out, and is paralyzed with amazement and with fright and with joy as he sees himself in a flying machine looking down at a green coral sea, white sands, and palm trees. The dream woke him up bolt upright in his bed. The dream stayed programmed in his mind, and it was that dream, possibly more than anything else, that began to set my father's mind to try to solve the challenge of flight.
It was in 1908, whilst on holiday in Austria with his father, that Igor first saw news film of the first public demonstration of the Wright brothers' aircraft. This early footage had a profound effect on his fertile mind, which made him determined there and then, at the age of 19, that he too would one day fly. It was a difficult task to convince his parents to send him to Paris, the focal point of European aviation pioneers. Eventually, they consented, and in spring of the following year, the first steps to fulfilling his dream had been made. Surrounded by the exciting atmosphere of that early Paris air show, he soon established contact with many of the pioneers of flight, developing a special relationship with Ferdinand Faber, who advised him to enroll at an aviation school near Paris. Although he was never allowed to fly, he learned an immense amount by watching pilots and engineers checking the rigging of their aircraft, tune up the engines, and test the new prototypes.
It was, for my father, an intensely dramatic period of time. Today, we take these things for granted, but my father was there in 1909, and he says that very, very often when one of these great French or British pioneers would be flying, the crowd, consisting of grown men and women, would be so emotionally affected that great, strong men would be standing there with tears of joy and pride running unheeded down their cheeks because of the fact that an age-old dream of mankind was suddenly coming true. Man was flying. He went back to Russia and started to build his first dream machine, the helicopter. Today, in retrospect, we can certainly have predicted that the machine, the first helicopter, would not fly. It was powered at that time by a 25 horsepower Anzani engine. Today we know that that is far too little horsepower. He built his first helicopter with his own hands, tested it in the backyard of his home for several weeks, eventually reluctantly decided it would not fly. The horsepower just was not there. He then built a second, somewhat more sophisticated helicopter, which he tested in the spring of 1910, this machine was also incapable of flight. He then temporarily postponed his first love, the helicopter, and switched to fixed-wing aircraft. He designed his first airplane, the S-1, and with a twinkle in his eye, he would often say that he designed his first airplane without knowing how to design it, and then he built it without quite knowing how to build airplanes. And then he climbed aboard this machine, sat down in the pilot's seat, opened up the throttle, and tried to take off and fly without ever having had even 1 minute of flight instruction in his life. The results were rather predictable. His first machine never actually flew except for one brief exhilarating moment when it was lifted by a gust of wind. S2, S3, S4, S5 all followed. In the space of 2 years, this man, surviving innumerable crashes, constructed, designed, built, and then flight tested something just over 7 basic designs before he finally taught himself to design aircraft, taught himself the hard way how to build them, and taught himself the very, very hard way of how to fly the aircraft.
Despite early setbacks, Sikorsky's S-series went on to be highly successful, the 6B winning first prize in a military aircraft design competition in 1912. But Sikorsky's resources were running out. All his early aircraft had been financed with his own money, and it looked as though his prospects in the still backward Russian aviation industry were limited. However, in the summer of 1912, Shidlovsky, the head of the Russian Baltic Wagon Company, offered Sikorsky the position of chief designer at his new aviation plant in St. Petersburg. Now with backing, Sikorsky built a series of single-engined aircraft, with the highly successful S-10 floatplane and the S-11 monoplane taking first and second prize at the International Aircraft Competition in St. Petersburg in 1913. It's indicative of Sikorsky's personality that he wasn't satisfied with these achievements, and after a near-fatal crash, he began to consider a new and innovative idea.
It was then, in a moment of inspiration, that he decided that aviation really, sooner or later, had to do the next great technical impossibility. An airplane had to be built with more than one engine, with 2, possibly 4 engines, and capable of maintaining flight after the loss of one of these engines.
Sikorsky quickly began to draw up specifications for his new design. The technical problems were vast. An aircraft of this size had never been attempted before, and many European flyers pronounced it as inherently unstable. But despite his critics, Sikorsky approached his employer, Shidlovsky.
It was a dramatic evening on the September 17, 1912, when after making a long flight and participating at this time in the military competition in St. Petersburg, I addressed this man and tried to persuade him that if we win the competition, we should take the prize and build the first big multiple-engine aeroplane. Now, I stopped several times, trying not to fatigue my host, but anyway, he encouraged me, go on, go on. So I went on, told more about the possible characteristic of this aeroplane, and finished my talk at midnight, saying that if we win the competition, let's spend the money on the construction of a big aeroplane. My host stood out and firmly stated no. Begin the construction of a big airplane immediately. The job ahead of us was a difficult job. There were no material at that time. There were no wheels available for an airplane of this size. There were no such thing as the high steel wires, so we had to improvise. High steel wires could be received from a piano factory as actual piano chords, and so forth and so forth. So, briefly, the big airplane was built in spite of the doubts expressed by many observers. Most predicted failure. The ship was built, the ship made the first successful flight on May 13, 1913, and it was the first successful 4-engine airplane in the world. And for the next year and a half, I happened to be the only pilot.
The Grand was an immense technical breakthrough in the history of manned flight and proved conclusively the advantages of multi-engine aircraft. And although production of his smaller planes went on, it was the development of heavy aircraft that was to continue to fascinate him. The Grand itself attracted worldwide attention, and although ridiculed in the West, it became the focus of national pride in Russia. Tsar Nicholas himself inspected the Grand in the summer of 1913, giving Igor a timepiece as a memento of his gratitude. In its short career, the aircraft was continuously employed in exhibition flights, demonstrating its unique ability to sustain flight with 2 of its engines shut down. Tragically, the Grand was destroyed on the ground before it was a year old, when an engine fell from an aircraft flying overhead and smashed through the Grand parked below.
Igor Sikorsky was already at that time busily constructing a much larger, much more improved version of the Grand. This is the beginning of the Ilya Muromets saga, the large 4-engined bombers that he built for the Imperial Russian Air Force from 1914 to 1917. These aircraft were, at that time, the largest, heaviest, and longest flying bombardment aircraft in the world.
The achievements of Sikorsky's Ilya Muromets series have been all but forgotten in the West. From 1913 to 1917, some 70 machines were built, arguably the most advanced aircraft to fly in the war. Sikorsky gathered around him a talented group of designers, Tupolev, Ilyushin, and Polikarpov, all of whom stayed in Russia and had distinguished aviation careers. The impact of these heavy bombers on the Russian war effort was limited by the massive nature of the Eastern Front and by the incompetence of the High Command, who insisted on mimicking Western techniques of air combat based around the small fighter. However, the aircraft carried out many successful raids and set several new world endurance records. As the war progressed, the political situation in Russia deteriorated. Wage cuts, food shortages, and the continued failure of the Russian establishment to find a solution to the debilitating war caused a spate of strikes. Aircraft production was halted as the war effort ground to a halt, and the desperate Russian government failed to act decisively.
In the late fall of 1917, the Bolshevik party staged a coup d'etat and took over power. And almost immediately after taking over power, a great number of prominent people and high officers began to be publicly executed as enemies of the state or as oppressors of the working class. And included in them were a number of pilots from the Ilya Muromets squadrons who were shot quite simply for no other reason than the fact that they were officers and in a way representing the old Tsarist regime. It became very clear to my father that his own life was in terrible, terrible danger. And this impression became even more positive. The threat became even more visible after a number of his closest comrades in the squadron of heavy flying ships were executed by the Bolsheviks. It was then that my father decided, reluctantly, that there was no other way to save his life than to leave Russia. He traveled to Murmansk and took passage on a British freighter, I believe the Oporto, and landed 1 week later in England, a free man.
In England, Sikorsky attempted to interest the authorities in his ideas, but he met with indifference, most likely because of the entrenched prejudice against the so-called backward Russian aviation industry. Later that year, he left for France, where he met with more success, when the French government commissioned him to design and build heavy bombers. He was only a week away from flying his first prototype when the armistice cancelled the project. Later that year, he left France for the USA, hoping, along with other refugees, to build a new life. Having arrived in New York in the spring of 1919, he spent the following 3 years trying to convince the established aircraft companies of the worth of his designs. He failed, and as a result, decided to start out on his own.
After some initial difficulties in 1923, my father was able to collect some $800 in cash and some $2,000 in very questionable promises. And a small group of some 12, mostly white Russian refugees, decided to donate their labor and they started to build the first aircraft in the United States. It was built largely in the open air on a chicken coop just bordering Roosevelt Field in Long Island. When the aircraft was finally completed, it was one of the larger transport aircraft, twin-engined transport aircraft. It could carry up to 12, I believe, passengers in a large and roomy cabin. This machine was eventually sold to a very famous racing pilot named Roscoe Turner, who barnstormed all around the United States with it. And eventually, when he was wondering what to do with it, he received a telegram one day from a gentleman named Howard Hughes. And Howard Hughes bought this, the very first aircraft built by Igor Sikorsky in the United States, disguised it as a German bomber, and purposely crashed it in an aviation epic called Hell's Angels.
After a long struggle marked by severe financial difficulties, Sikorsky Aircraft scored its first commercial success with the S-38 amphibian, which first flew in 1928. Demand for the aircraft was so great that Sikorsky had to move to larger premises in Connecticut. In that same year, his company was bought out by the United Aircraft Company, providing much-needed financial support while leaving him in control of the subsidiary. The early 30s saw the boom in flying boat production, as this seemed to be the solution to transoceanic aviation before long runways were built. Sikorsky, already familiar with large multi-engine aircraft design and backed by influential names like Lindbergh, decided to enter this rapidly expanding field.
We built a flying boat. It was a good one, called S-40 flying boat. And by the way, this is this model here, which hangs over my head nearly. I was among the passengers during the first flight of this boat from Miami to Kingston, Jamaica, Barranquilla, Colombia, and Panama Canal. The head of the expedition and chief pilot was Charles Lindbergh, and I had a great chance, and I would say privilege, to spend a great deal of time with him, to learn, to respect, and admire this man in every respect, in every connection. Tremendous. So every evening, we were sitting together with Lindbergh on a table with the rest of the crew, in which he and I were usually taking the menu, turning it upside down, and starting to make sketches or plans or specifications for a transoceanic flying boat. We both believed that transatlantic flying is possible. At that time, a flying boat seemed to be the right solution, and we hoped and believed that it can be done. Consequently, when we came back from this trip, Lindbergh and I decided that he will sell the idea to Pan American Airways, which may have had it anyway, but Lindbergh was the advisor of them, and I would do similarly to United Aircraft, insisting that we take a job like that, because I believe that we can fulfill the contract.
And indeed, the contract was placed and fulfilled. And in 1934, the first model, designated S-42, was wheeled from its hangar and placed in the water. With the unusual combination of very long range and fairly high speeds, the ship fully confirmed the hopes that they had. It was capable of flying across the Atlantic Ocean. It had the lifting capacity, operated at over 160 miles an hour, and had the ability to enter service immediately.
1934 was still a pretty hard time for American aviation. There has been a considerable amount of criticism, some of it undoubtedly unfriendly. And I remember that in July, we received a letter from the president of the National Aeronautical Association asking to make efforts to establish world records, because this was the recognized yardstick of the quality of the ship. Now it so happened that on the evening of the same day, in the morning of which we received this letter, we were able to reply that in line with your letter, the company tried to establish world records, and as of this evening, we added 8.
With the help and support of Lindbergh and Pan American Airways, Sikorsky went on to build a series of highly successful long-range flying boats which pioneered scheduled passenger services across the Atlantic and Pacific Oceans. Despite his successful fixed-wing designs, Sikorsky could never forget his dream of vertical flight, and from 1929 he began to make a series of sketches and patent applications. Some of these drawings show a remarkable resemblance to the VS-300, which he constructed 10 years later. The technical difficulties involved in the design of the helicopter were immense. The engineers and technicians working under Sikorsky were absorbed by the flying boat production program, and he found himself once more designing and testing on his own.
The helicopter was not a project which I could just to charge to the engineers to do something about, and to test pilot to test and to do something about it also. It was a thing which called for attention, I would say love, I would say all energy, knowledge and support which a man can put in. And of course it was my ambition, my plans, my desire to live my life again, to design an aircraft without knowing how it should be done, because no one really knew properly how it could be done. Helicopter was at that time one of the impossibles still. Many people considered that no helicopter with good, real control characteristics could and would ever be constructed. Other pessimists said that even if you will construct a helicopter, no one would need this helicopter. I remember a good friend of mine and a very prominent designer, scientist in aviation asked, when would the helicopter go faster than the airplane? Do you know that? I said, yes, I know. The answer is never. When would the helicopter be more efficient than the airplane? Do you know that? I also said, yes, I know that. Never. But I said that helicopter will do a number of jobs which no airplane will do, and which in fact nothing else will do except a helicopter. Consequently, that was the idea. While I resumed thinking actively about the helicopter around the year 19, I would say, well, I thought about it all the time, but more energetically. It was beginning 1929.
Sikorsky was by no means alone in the field of helicopter development at this time. Louis Brenier had constructed a helicopter in 1907, which lifted half a meter off the ground. In 1933, Brenier returned to helicopter design and built a successful machine. Impressed, the French government ordered development, but difficulties in stability and eventually the advent of war in 1939 ended whatever future it may have had. In 1930, Corradino d'Ascagno constructed a helicopter capable of free flight and a limited degree of maneuverability provided by a configuration of 3 tail rotors. In Germany, the famous aviator Heinrich Fokker designed a highly efficient machine which flew in 1936. It consisted of 2 contra-rotating blades mounted on an old biplane body. The propeller was not for directional control, but to cool the radial engine. Used largely as an exhibition piece at Nazi rallies, the FW-61, as it was known, reached the height of its fame when pilot Hanna Reich flew the machine inside the extremely confined area of an exhibition center. Germany successfully overcame the twin problems of maneuverability and stability and built 2 production models during the war. The Kolibri was a small 2-seater reconnaissance and anti-submarine helicopter, and the FA-223, a scaled-up version of the FW-61, capable of a payload of over 1,000 pounds. The military uses were obvious, and mass production of over 400 a week was ordered, but Allied bombing disrupted the production, and only 10 were ever built. Isolated from this European experience, Sikorsky continued to develop his ideas throughout the 30s, and in 1939 he began construction of his first prototype, the VS-300. Details were changed daily, and before the decision on its final form was made, 18 different configurations were tried and abandoned. In the autumn of that same year, his helicopter was wheeled out on the runway at Sikorsky's plant for its first test run.
It was then in September of 1939 that the VS-300 lifted off the ground for a few brief seconds and a few brief inches. And in my father's words, the helicopter was born once again. I'd like to quote my father's exact words when he said that it was a wonderful way to relive one's life all over again, to design a new flying machine without quite knowing how to design it, and then building a new flying machine, the helicopter, without quite knowing how to build it, and then climbing into the seat of this machine and trying to lift it into the air as a test pilot without ever having flown a helicopter before in one's life.
The VS-300 had a single three-bladed main rotor and a one-bladed tail rotor to counter torque and provide a degree of rudder control. The pitch control, which alters the angle of attack of the rotors, proved successful in providing lift, but no degree of maneuverability could be obtained. It simply went up and down. 12 weeks later, Sikorsky survived yet another crash when the machine was wrecked by a gust of wind. Rebuilding the machine and adding two horizontal rotors on tail outriggers, Sikorsky, although now in his 50s, continued to pilot the test flights of his VS-300. Viewing film of the latest modification, the head of United Aircraft commented that although there was now more maneuverability and stability, at no time did he see the machine flying forwards. Sikorsky's non-defeatist reply was that it was a minor problem that he had yet to solve. But it wasn't quite as easy as he had predicted. Although breaking the world endurance record held by the FW-61 and achieving a flight duration of 1 hour, 20 minutes, the problems of forward flight were not solved until many months later. Throughout these periods of testing and retesting, Sikorsky was always keen to demonstrate other aspects of his machine. Landing in confined spaces, carrying out repairs while hovering a few feet above the ground, and demonstrating its life-saving capabilities in water. By now, he had become convinced that the solution to the problem of horizontal flight lay not in extra tail props, but in a more flexible main rotor, which could provide both lift and directional control. Eventually, he developed an effective system that was to launch the helicopter into the practical world of flight, the cyclic pitch control. By varying the angle of attack of each rotor blade, a remarkable degree of maneuverability was at last obtained. With this breakthrough, Sikorsky was now able to incorporate the cyclic pitch into the now familiar configuration of the VS-300, and the new version flew in the autumn of 1942. Within a month, he had received his first government order for the XR-4, a much larger two-seat version of the VS-300. It was the breakthrough he had longed for. Sikorsky and his division of United Aircraft gave up the production of fixed-wing aircraft and concentrated on a new area of flight, the mass production of helicopters. The XR-4 was evaluated extensively during the latter part of World War II by all branches of the U.S. Armed Forces and was used operationally to rescue downed pilots, reconnaissance, and support for the U.S. fleet. In 1944, this highly successful addition to U.S. air power achieved a new record by becoming the first helicopter to land on a moving ship. This rare footage being some of the first shot from a flying helicopter. Impressed by the XR-4, the British Royal Air Force bought the machine in 1945 to carry out extensive trials. It was to be the beginning of a long association with Sikorsky helicopters. The XR-5 followed, which was larger and more powerful, and soon proved effective as a multi-role machine in Korea, serving with both US and British forces. The British bought large numbers of the new model, which was eventually built under license in the United Kingdom by the Westland Company and renamed the Dragonfly. In November 1945, the XR-5 came to public attention during a dramatic rescue when, in heavy seas, an oil barge broke free from its tow and was driven onto Penfield Reef off the coast of Connecticut. Despite the efforts of the Coast Guard, the barge rapidly broke up and no boat could reach it. Jimmy Viner, chief test pilot with Sikorsky, took off from the nearby factory with Air Force Captain Jackson Bagel manning the hoist. Instructions had to be dropped to the stranded crew as no civilian rescue had ever taken place before. Making 2 flights in heavy rain and strong winds, Sikorsky's brainchild saved the entire crew. From the beginning, the possibilities that the helicopter provided for saving life had inspired his work, and at last, it seemed, his dream had been vindicated.
I'm ringing the bell. Yeah, this is Scramble, Barry. Yes, go ahead, old boy. Aircraft crash. Single seater, 10 nautical miles west.
Scramble, Pedro 592, aircraft crash at Tintagel, 1 occupant.
If a man is in need, thinking, something like that, well, the airplane can come in and throw some flowers on him. That's just about all. A direct lift aircraft could come in and save his life. Direct lift aircraft can go anywhere, anytime where there is air. And this commodity is fairly widespread over our wonderful globe. Even if the helicopter cannot land, and these were the ideas which I had fully before I started it, helicopter can use the hoist, in other words, or a cable, and can contact any place, on the ground, on a roof, on water, on a treetop, absolutely any place. Helicopter is the only thing which can do that.
In the first 20 years of the helicopter's operational use, it is estimated that it saved over 100,000 lives. In a military role, it reduced the death rate of wounded men from 4.5% in World War II to 2.5% in the Korean War. The list of civilian mass rescues is staggering. Almost 10,000 people were saved at Tampico, Mexico, during the floods of 1955. Thousands were airlifted to safety from the flood-stricken Low Countries. Rescues from ships, oil rigs, houses, and from accidents of all kinds are everyday headlines today, and it is now estimated that over 1 million human lives have been saved, a record for which Igor Sikorsky was justly proud.
In the later years of my father's life, he would often be visited by the air crews that had piloted his helicopters on very unusual and sometimes daring and sometimes dramatic rescues. His face would light up, and sometimes he would become proud and deeply emotionally involved as he heard these tales, stories of tremendous heroism, and sometimes very great danger, and sometimes incredible airmanship, as military and civilian pilots would come here and describe in their own words, pilot to pilot, what they had done or what they had been able to accomplish, very often in weather that would have probably prevented any other form of vehicle, any other form of transportation from having saved that particular person's life.
1950, Sikorsky, pressured by demands for larger and more powerful helicopters, had designed the S-55, which could carry up to 8 passengers and 2 crew. Going into mass production in 1952, it was built in large numbers in both the US and Great Britain, where it was known as the Whirlwind. Called on to fulfill many varied military and civilian tasks, the Whirlwind became the mainstay of both the Royal Air Force and Navy. But as technology moved forward, it soon proved inadequate for modern weapon systems. And in 1955, Sikorsky produced an updated version, the S-58. Although similar in appearance, it was to be more powerful in order to carry double the payload over an extended range. In Great Britain, Westlands built an even more advanced model known as the Wessex, which, powered by the new Napier turbine, had considerably improved performance. Both the 55 and 58 and their British counterparts had long and varied careers, and the aging Wessex can still be seen around the coastline of Great Britain, although much of the rescue work has now been taken over by the Sikorsky Sea King. With the helicopter and Sikorsky's reputation firmly established, Igor felt able to take a quieter role, and in 1957, at the age of 69, he retired. But not surprisingly, this was not to be the end of his design career, for he was determined to push the parameters of helicopter lift capability to their very limits. In 1957, he began preliminary design work, and a year later built the first prototype of a new piston engine research vehicle known as the S-60. Funded jointly by Sikorsky and the US Navy, it was to have an exceptionally heavy lifting capacity, and with the development of the more powerful turbine engines, Sikorsky was able to produce the S-64 Sky Crane, which first flew in 1962. Capable of carrying a load of 10 tons, its unique fuselage enabled it to carry bulky cargoes and self-contained hospital and command pods for the military. It also had a unique set of rear-facing controls, allowing great accuracy when offloading cargoes. Since its inception, the Sky Crane has been used extensively in offshore oil rig construction and played important roles in the Vietnamese conflict of the 60s, recovering 340 downed US planes from behind enemy lines. Once again, Sikorsky's unique talent had produced a remarkable aircraft.
It would be impossible to even start to enumerate the various missions which a crane helicopter can perform, because they are so really limitless, so immense in numbers and in variety. Our helicopter at present can carry a load of 10 tons. I predict that in the near future, the load can easily be doubled. In fact, we could do it anytime. We could build now a helicopter with 20-ton lifting capacity, and in the foreseeable future, we can build ship carrying 40, 50, eventually 100-ton cargo.
Although he remained active as a consultant for the next 15 years, the Sky Crane marked the end of an era, being the last major design project that Igor produced. In the years since his retirement, the helicopter has undergone rapid change, spurred on by the defense strategist's need for faster, more offensive machines. Today's industry has invested millions in new technology, pioneering the development of advanced electronics, fiber optics, millimeter wavelength radar, and developing existing systems of advanced navigational aids and automatic flight control. To oversee all this, complex onboard computers constantly update the pilot with flight information, and this new technology is continually changing the face of modern helicopter design. The company that Igor founded now produces just 3 basic helicopters: the S-76, a light, high-speed civilian transport machine, and its military derivative, the H-76, fitted with various weapon systems designed to capture the lucrative overseas market. The Super Stallion, driven by 3 gas turbine engines, giving a lifting capacity of 17 tons, and the largest helicopter of the Western world. Serving with the US Navy as a minesweeper and submarine hunter, it also acts as a fast deployment vehicle for the US Marines. Equipped with mid-air refueling systems, it has potentially unlimited range. The Black Hawk, US Army's main battlefield assault helicopter, powered by 2 1,500 horsepower engines, draws on lessons learned in the Vietnam War and is faster and more reliable than anything that's gone before. The Seahawk variant is adapted for naval support roles, including submarine detection. Its all-weather capability and winch-down landing system enables it to operate in extreme weather conditions.
Designated H-860D, the Nighthawk, a prototype search and rescue design packed with some of the most sophisticated technology available at the end of the 80s. Its digital flight controls and infrared night vision paved the way for the development of the H-60K, which first flew in 1990. The first production model was completed in February 1992, when evaluation trials began. In 1994, the US Army's 160th Special Operations Force began its training. Since then, there have been no reports of its true capabilities. However, there's no doubt that its integrated avionics system, incorporating flare or forward-looking infrared, its terrain-following radar and air-to-air ground-ranging radar make it the ideal choice for incursion and special operations use. Modern-day helicopter design programs for the military also draw on the technical developments made by its fixed-wing counterparts. In 1991, Boeing and Sikorsky jointly won the contract for a new combat helicopter for the US Army. The result is the RAH-66 Comanche, a stealthy helicopter at the cutting edge of current technology. First flown in 1995, it is expected to enter service in the early part of the next century. With the RAH-66 and the many variants of the Black Hawk, Sikorsky has a major stake in military helicopter production that will certainly fulfill Army requirements for the foreseeable future. Their incredible agility and speed, complement of armaments, and a plethora of high-technology combat equipment, in addition to their satellite navigation systems, have set the standard for military helicopters of the next century. Sikorsky is also setting the standard for civilian helicopter transport. The S-92 Helibus program was announced in 1992 and originally envisaged as the Growth Hawk. The first of 5 flying prototypes are expected to fly in early 1999, with certification expected in the year 2000. The Helibus will be a low-cost transport that will compete favourably with short-haul commuter aircraft and will be ideal for oil rig service and urgent cargo. Based on the well-proven Black Hawk, which began its pedigree in the 70s, the S-92 will incorporate a considerable amount of its navigation and radar technology, extending the long line of Black Hawk variants well into the next century. All a far cry from those early days at the beginning of the century. Igor's legacy is a team of people with the same burning desire that he had as a young boy in Kiev, with his earliest dream of flight. A dream which his son Sergei explains literally did come true.
Many years later, my father was aboard one of his giant clipper ships that was being delivered to Pan American Airways in Florida. He flew on that machine as pilot in command from Stratford on its first delivery flight to Baltimore, where they landed, took on some fuel, and then took off again to complete the flight. As they were beginning to approach Florida, my father gave the controls to the 2 Pan American pilots who were much more familiar with the local traffic and the local area and the regulations, and stepped back into the empty passenger cabin to try to get a feel for the comfort level. And as he started to walk back through this wood-paneled cabin with its deeply upholstered chairs, a strange and very weird feeling came over him, quite literally goose pimples running down his spine. And it was all so terribly and hauntingly familiar. And he stepped to the window, and he looked out, and he looked down at a green coral sea, at white sandy beaches and palm trees, as the aircraft made its final approach into Pan American's Caribbean base at Dinner Key, just outside of Miami, Florida. He stood there for a very long time, absolutely impressed with the fact that this was exactly the cabin and exactly the vibration and the noise that he had dreamt of so many years ago as a small boy in Kiev, Russia.
Igor Sikorsky died in October 1972 at the age of 84 and was buried near the spot in Connecticut where he fulfilled his dream of vertical flight.